Today's lesson is section 5.1. It's called Polynomial Functions. The first thing we're going to do with polynomial functions is classify them by degree and the number of terms. So let's talk about degree first. So p of x is function notation, and p stands for polynomial. So it's a polynomial and the independent variable is x. So the degree is the highest power, and we can go ahead and name each degree in the polynomial. So if it's x to the fifth, we call this term the quintic term. So like quintuplets. So if it's x to the fifth, we say it's a quintic. Now I'm just making up numbers, so it could be anything here. Minus 4x to the fourth. So the fourth power, like 4 quarters and a dollar, this is the quartic term. So we got the quintic term, the quartic term, plus 7x cubed. So the next one would be, I just said cubed, so that's the cubic term. And then the rest of them we studied before. The quadratic term, which is the x squared. I'll do a plus again, plus 5x squared. So that's the quadratic term. And they'll throw a minus in this one, minus 4x, so that's the linear term. And we'll do another negative, minus 1. And this is the constant term. The book that we use doesn't name things past x to the fifth power, so it could have x to the sixth, x to the seventh, and keep going, but these are the names that we have. So I'm going to get a cover sheet here. So if it's just this one thing here, we would say, oh, that's a constant. -1, that's a constant. So you could say p of x equals -1. That's a constant polynomial. But then as you move across here, you're like, well, what if it had this part? So that'd be linear, right? It'd be a linear polynomial. And then if you add in the next part, you would say it's a quadratic polynomial. And if we go to the next part, we'd say it's a cubic, etc., etc. So the highest power is the name, but you can say, oh, what's the cubic term? And you would go right here. But the overall name of this would be a fifth degree polynomial or a quintic polynomial. You can also classify by the number of terms. So the number of terms, if there's one term, like 3x, that would have one term, we call that a monomial. If we have a couple of terms, x plus 4, that has 2 terms to it, so we call it a binomial. If we have 3 terms, maybe a couple of things out of the way here. If we have 3 terms, we have x squared minus 7x plus 18. That has 3 terms to it. Call that a trinomial. And then anything past that, we just call them polynomials. So you can have x to the 18th plus 7x to the 5th plus 45x squared minus 18x plus 4. Anything like that, we would call that a polynomial. We don't really have names for those other parts, but every single one of these is a polynomial. A trinomial is a polynomial, a binomial is a polynomial, a monomial is a polynomial. Basically, what a polynomial is you have whole number exponents. Okay, so we have whole number exponents. Whole number exponents, that's what makes it a polynomial. So we don't have any fractional exponents or decimal exponents or negative exponents. They're all whole numbers, including 0, right? Because you could say right here, this is x to the 0 power. So it's all in order. Polynomials kind of follow the decimal number system. So there's an order to it. They go by power, just like the tens place, the hundreds place, the thousands place, etc. So we're going to classify our polynomials by degree and by the number of terms. But again, every single one of these is a polynomial. So a trinomial is a polynomial, right? Because it has the whole number exponents. The next thing we can do is we can talk about the end behavior of a polynomial. So the leading term is the first term. The exponent and the number in front, the coefficient, tell you about the end behavior of the function. So let's talk about end behavior. Well, no, before we do that, let's just name some things here. So if I have x cubed minus 8, so this would be an example here. So I have, and we'll call this A, example 1A. So if I have x cubed minus 8, that would have two terms to it. So it's a binomial, and it has the highest power of 3. So we call it a cubic binomial. And of course, it's a polynomial too, but more specifically, it's a cubic binomial. If you had, like x squared plus 4x minus 7, right? This would be b. This is a trinomial, and it's a squared, so it's a quadratic trinomial. Trinomial. Okay, so that's how we can classify it, by the number of terms and the highest power. It's all about the first term here. That's how we give it its name. It's a cubic, it's a quadratic, it's a quartic, whatever. So it's the highest power that's really powerful. The end behavior of the function. Oh, BT dubs. Sometimes my students say that my videos are kind of boring, so I'm going to do some random spinning. Isn't that fun? Random spinning. And if you flip it on this side right here, it has the red light, so the red light goes up faster, doesn't it? There we go. Random spinning, just like the iCarly show, random dancing. Look at that. Isn't that fun? Okay. Whoa, that went away. So now we're going to talk about the end behavior of the function. End behavior. Okay, so the end behavior of the function. This is what's happening to the function on the end. Well, if we have x to the first power, right? So we have p of x, so it's polynomial, right, is x plus 8. Well, that's just a line. So it starts at 8, slope of 1. It's not drawn perfectly, but that's just the idea. That's the end behavior of the function. So you would say, if you look at the right side of this, it's up, right? The right side is going up. If you look at the left side of this, the left side is going down. So on the left side it's going down, on the right side it's going up. Well, if you have something that's squared, then I don't know, it doesn't matter, just because this thing's so powerful here, it doesn't even matter what I write down here. So I can do 3x minus 7, okay? So if you have something that's squared, it's going to be a parabola, and in this case it's a happy parabola. So it's some kind of happy parabola because it's positive in there, and the each side is going up, so it's up on each side, up on the right, up on the left. And what happens is this pattern keeps going for all different functions. If you have even, so if your leading power is even, the two sides match. If the leading power is odd, then the two sides are opposite of each other. So that means if you have something p of x with an x cubed in it, it's going to do this kind of thing. And it kind of looks like two parabolas smashed together, but it's going to be up on the right and down on the left. If it's x, p of x, something to the fourth power, it's going to do this kind of thing. And it's going to be up on the right, down on the left. Now, of course, you can flip any of these over anytime you want to. Okay, so I made a little dance out of this. Let me see if I can show you the dance. Let me see. Let me bring this. I don't think I can do that at the same time. Okay, so there's basically different scenarios here. The two sides could be up and up. Let me put this over with the other side, erase that out of here. I'm trying to think of the best way to communicate this through this. This is one of my early videos, so we'll have to. So I have odd on this side, right? Odd, and then I have even over here. So even, the two sides go the same. So if it's even, then the two sides go up and up, or if you multiply by a negative in the front, they would go down and down. So this would be positive and even, and this would be negative and even. And then for the odd ones, for the odd powers, the sides go opposite of each other. See, like the two sides are opposite, or like a line, the two sides are opposite. So it's going to be down and up, or up on this side and down on the other side. So this one would be positive and odd. And this one, since it's flipped upside down, it'd be negative and odd. All right, so I made a little dance for this. I think I need to if I bring this up like this, and then go like this, then you can see me. This is what I look like. Okay, so I think since I brought myself into the picture, I need some more random spinning. Yay! So here's how my little dance goes. If you have positive and even, here, let me pause it for a second here. So we have positive and even. So you can see it's, whoa, positive and then even exponent. It goes like this. Touchdown, each side is up. Negative and even, it's going to be flipped upside down. So it's frowny face, it's like down. Okay. And then the next one is positive and odd. So the leading thing is positive and odd. So it's going to be up on the one side, but down on the other. Okay. And I think my hands, no, it'll be up on the, I'm looking at how this is, up on the right, down the left. Okay. And then the other one, it'd flip it upside down. So this is going to be really interesting because it's backwards in the camera. So hopefully this will work out. So here's how the song goes. I'll get myself back here. So it's positive and even, right? Negative and even. So it's flipped upside down. And I go like this. Positive and odd. Negative and odd. Do the polynomial. Right? So it's positive and even, the two sides are up. Negative and even, the two sides are down. If it's positive and odd, it's up on the right, down on the left, and you shake your little tushy, right? And then you flip it upside down for the other one. All right, so that's the polynomial dance. So there's your end behavior. Okay, flip this back like this. Yay, spinning! Woo! The last thing I'm going to do is I'm going to do the calculator business here, and I'm going to graph y equals negative x cubed plus 12x. We're going to graph this in the calculator, and I'm going to find out some information about it. Okay, it's negative and odd, so we know that it's going to be up on the left side. It's going to curve like so and be down on the right. So it's going to have kind of a curve like this. Not excited about that curve. It's going to go something like this. But it's going to be up on the left and down the right because it's negative and odd, so it's flipped upside down. All right, so let's graph it on the calculator and see what happens. So go to y equals. We're going to type in negative 3x squared. No, x cubed. So I use the caret key, cubed, push myself out. Oh, it's not negative 3. It's just negative. Delete. There we go. And then plus 12x. So it's negative x cubed plus 12x. All right. So now I'm going to go to graph and see what happens. So it's down, up, down. So it is up on the left and down on the right, but I can't really see the two parts there. So I'm going to count here 1, 2, 3, 4, 5. So 5 is about there. So I'm going to change the window so I can see things better. So go to the window key. I'm going to go negative 5 to 5 in the x direction. And then I'm going to do negative 15 to 15 in the y direction. Now hit graph and see what happens. Oh, can't quite see the top yet, can I? So I'm going to go to 20, back to window. I'm going to do negative 20 to 20, scale of 5, because it kind of was getting a lot of line dashes in there. Okay, so there's my graph. So it's down, up, down. One of the things I'm going to find about this is, well, we talked about the end behavior. Okay, so the end behavior is it's up on the left, and it's down on the right. So that's the end behavior. Behavior doesn't look like an R, does it? There we go. And now we're going to find the intervals of increase and decrease, but before I do that, I'm going to find the relative mins and maxes, or the turning points as they're sometimes called. So this thing is going down and it turns right here, has a minimum value right there, and then it takes off again. And then right here it goes up to a maximum value, turns, and goes back down again. So we're going to find these turning points. And we do that using the calculate feature right here that we've used before. So go to second, calculate, and I'm going to choose minimum because I want to find that minimum spot. So I got to move to the left side of the minimum. Right now I'm on the right side of the minimum, so I'm moving over to the left side. Hit enter, which puts the little mark on there. You can see the mark. Now I go to the right side. And then I go back and I hit enter for a guess. So it's, because of the calculator running, it's negative 2 to 16. Negative 2, negative 16. Okay, so I'm going to make myself a decent graph here. So there's 0, 0, and it's negative 2, negative 16. So it's 1, 2, and then it's down a bunch. For time purposes, I'm just going to say that that's 16. All right. So the graph comes down to this lowest point, and then it goes back up through 0. We're going to pretend that it went through 0. Now I'm going to find this side over here, doing the same thing. So I'm going to go to second, calculate, maximum, And I need to go to the left side of it, so I move my little butterfly guy over here. And right there. I go back, and I can find the maximum. So it's 216. So this has symmetry to it. So we're going to go over 2 and up 16. We're going to call that 16. All right. So -2, -16 is the turning point, or the relative minimum. And then this point right here. So I left off with this graph where the function comes down, the lowest point, or the relative minimum, is -2, -16, and then it goes up, and then the highest point in this local area here is 216, and then it goes back down again. So it matches negative and odd, so it's up on the left and down on the right. If this was multiplied by -1, it'd flip it upside down, and it would be up over here and down over here, but this negative makes it be up on the left. Right, it's going up on the left, down on the right. That's the end behavior of the function. The last thing that we're going to do is talk about the increase and decrease intervals. So I'm going to grab a highlighter right here, and the function, you read a function from left to right, just like an English sentence. So you read a function across like this, only in one direction. So we look at the function, we say, hey, the function is going down on this interval. The function is going down on this interval. All right, so it's going down on those two intervals. In the middle interval, it's going up. So y, or not y, but the x values, x is greater than or equal to 2, the function is increasing. No, greater than 2, it's decreasing, my bad. Decreasing. And when x is less than or equal to -2 is also when it's decreasing. So when -2 and below, it's decreasing, and -2 and above, it's increasing. And so then in between, it is increasing. Raise increasing. All right, so that pretty much covers everything that has to do with the basics of a polynomial. The first thing we did is we classified by degree and the number of terms, and then we talked about the end behavior, and I did my little dancy song thing. And then we did, for a specific function, we graphed it on the calculator. It found the lowest point on in a section, not an interval, but a lowest point in a section, and then a highest point. And then we did in between.